Hi, I thought it would be good, since we inadvertently missed a lecture this week, that we should review the ER diagrams, because I did have a couple of requests from students to go through these. So here it is in video form. So let's first of all go through the pieces that hang together for an ER diagram. The first thing, the obvious thing, is an entity, okay? And remember that an entity is usually a real world object, something that we can point to in the real world that exists. And the way we draw that is as a rectangular box with, let's not do that, let's erase that. And the way we draw that is we put the name of the entity inside the box. Okay, remember this is for logical diagrams. This would be the next step, or perhaps a first step in figuring out what the database looks like. It's not going to tell you what the tables are, but it may imply what the tables are. And once you've got a nice understanding of the relationships between the different pieces in your data puzzle, then you can start thinking about creating a physical diagram, one that will allow you to write SQL create table statements. Okay, so the next one on the list is the weak entity. And here we've got the same idea. It's an entity. It's something that we can point to in the real world, but it's not as easy to identify, or rather it only gets its meaning from another entity, right? And the example we'll see later on in the employee database is dependents, right? Dependents, children and spouses of employees are deemed to be dependents in that database, and they have no existence as far as the company is concerned outside of the employee on whom they are dependent. And the way we draw that is with a double box, and as I said, the example we had was dependent. Okay, and we write the name inside the box. Once we've got the entities, then we can connect the entities up with relationships. Right, so here's a relationship diagram, or here's a relationship, and it's a diamond, and on one side you have one entity usually, on the other side you have another entity. It can be the same entity, right? The employee the employee table, the company database, has a recursive relation, but it's between two, sometimes more, but usually two entities. Okay. The next on the list is related back to the weak entity, and we could call it a weak relationship, but in fact it is an identifying relationship. Right? Remember, the weak entity has no existence outside of some other entity in the diagram. And this relationship, the double diamond, is the thing that identifies the entity that the weak entity is related to. Okay, so in the company database, we need the social security number of the employee as part of the composite key into the dependence table. Okay, then we have various different sorts of attributes, right? A standard attribute is just an ellipse with a line connecting to the entity that it's related to. If the attribute is a key for the entity, then we underline the name, right? So this is attribute, and this is a key with the underline. Okay. If one entity can have lots of different versions of this attribute, so it's a multi-valued attribute, then we don't write lots of ellipses hanging off at attribute 1, attribute 2, attribute 3, attribute 4. We just say, okay, this is the name of the attribute, and it's possible for this entity to have multiple values of this attribute. And the example, I think, was location in the in one of the examples. Sometimes we want to compose a given attribute out of smaller attributes, and the example we had was the person's name, right? And they may have a first name, a middle name, and a last name. Right, but you can see here that it's possible that there might be many others, and I'll point you to. I've already pointed you to an example of how complex naming can be when we need to put it into a database. Next up is derived attributes. So here, these are things like that use things like minimum, maximum, sum, count, those aggregate queries or aggregate values that we use in SQL. And these are, again, drawn as an oval, but this time a dashed oval, and we put the name inside of it. So number of employees. Right, might be something that we could calculate from the existing data. There's nothing particular about it. By that I mean there's no, we don't enter any data about a derived attribute into the database. It's already, all of the information is already there. We're just calculating this derived attribute from pre-existing data. Okay, and then we've got some examples of relationships. Right, we've got the first one is saying that E2, entity 2, has total participation in R. Right, that means it's got to have that relationship. The next one is saying that for every one E1, we have n E2s, and then it's possible also to have a range of values on the cardinality, the multiplicity of values. Okay. So that's the first part of this review, and I will go on and talk about the two diagrams we've looked at in detail in the next couple of videos.